There are many reasons why people would want to analyze climate data. For instance, we might want to find long-term climate change, like in this upward trend shown here, or specific years that behave differently, like the one circled in red. We will call these interesting behaviors anomalies, and our task would then be called anomaly detection. But these data sets we need to analyze are massive. It really wouldn't be practical for someone to go through all this data and find everything of interest. Thus, we need automated methods based on statistics to find these anomalies. My name is Joe Hidakatsu, and I worked with Professor Clayton Scott for this summer's SURE program. And this project itself is a joint collaboration between the University of Michigan and the Carnegie Institute for Science. The video shown here is of something called the Normalized Difference Vegetation Index, or NDVI. This is a satellite-based measurement that reflects the amount of vegetation in an area. The more red it is, the higher the NDVI, which usually means more plant growth, and the more blue, the lower the NDVI. The data in this video contains 650 weeks, which is about 12.5 years, of weekly data over a 203 by 391 grid. So overall, that means there are 51 million numbers in that data set. And even if we were just to look at each time series plot individually, there would still be 80,000 time series, or almost 80,000. And this is why we need automated methods to detect these anomalies. This data shown also appears to be consistent with global warming, as shown in this time plot for a specific location. This summer, I've used some principles from statistics and machine learning to detect some of these anomalies. This video shows the output of one of these methods with high peak values in red and low ones in blue. Here, if we zoom in on an area for a particular year, we see a patch of blue, which represents low values. If we examine a time series from one of these locations, we can see the value that the blue was indicating. We see a year where the NDVI does not reach a very high value. We hope to develop more automated methods like these in the future to be able to analyze massive sets of climate data.